Hi everyone, today we will talk about decentralized lending protocols. That's my favorite topic actually, because I was like 20 years experience of working at banks. So this is, I would say, on-chain banks, but we know that in reality that you can call a bank anything that have a license from a central bank of a certain country. Here we understand that it's not real banks because they do not have a license, but still they perform quite the same functions which ordinary banks are doing in classical world, in the real world, in the classical finances. So what do actually lending protocols? How do lending protocols work? We have two parts. We have the lenders and the borrowers. Lenders, that's actually, in other words, that's the depositors. That's the people who bring money to our lending protocol. Or you can imagine that if you have a deposit in a real bank, you're a depositor, so you are the lender. You are actually the part which provides the funds for the banks to function, the liquidity. And we have also other side. That's the borrowers. That's the people, the companies. If we talk about the real world, who take loans. If you have a credit card loan, a car loan, mortgage, that's all the same. Someone funded these loans with liquidity, and you use this liquidity to take a loan and bought something, this money. So that here is the same. How it works, lenders get interest rate, and that's the reason why they bring money to our protocol and to the bank. And borrowers pay the interest rate. Actually, that is why that's their payment for the money. That's the price of the money. Usually, as far as we know, and it has to be to make this business sustainable like this, is that borrowers pay higher rates than the lenders. And the difference is actually what the bank earn. So that's interest margin, or if we talk about the smart contract and the lending protocol, we call it reserve factor. So this is the money protocol earns on positive difference between borrow and lending rates. So it's very simple. The lenders, those who provide liquidity, the borrowers who take this liquidity as a loan, borrowers pay interest, lenders get part of this interest, and part of the interest goes to the lending protocol itself. The same structure is with the real bank. It might be more complicated, taking into account different types of deposits, different types of loans, but still at the end, the principle is the same. In our topic, this lecture, maybe that will be 2 lectures actually. We'll speak about 4 lending protocols. Defina, that's our own protocol, which is developed for 2 years by Distributed Lab. We support this as a white label, and we will have a practical exercise with it, looking at how it works. AVV3, version 3, compound V3, and the blend, which is the new protocol introduced at the end of April or even in May. And the interesting thing about this protocol, that this protocol allows you to take loans with the NFT collateral. So it's NFT lending. Above protocols work with the so-called fungible tokens, or tokens which you can change one for another. It's no problem. But NFT is a different story. That's this CryptoPunks or any other collections, which costs lots of money, and you can use this NFTs not just to speculate, sell, and buy, but now you can even take a loan with the collateral. So let's go on with the Defina. First, we will go with the principles, how it works, and then we will have a practical case and try to understand how these principles work on a test net. So Definer and all other protocols actually built on the principle of liquidity pools. So we have here in this example, that's the real one. If you go to definer.com, you will see the instance, the fork of Definer protocol deployed on Binance Smart Chain, and it works with the real money. It has actually 7 liquidity pools: BNB, Ethereum, DAI, USDC, USDT, Bitcoin, wrapped on Binance Smart Chain, and BUSD. So it's 4 stable coins and actually 3 volatile crypto assets: Bitcoin, Ethereum, and BNB. Of course, we have to remember that all DeFi works taking into account principle of printing tokens as soon as they get another tokens. In this case, we have so-called LP tokens, liquidity provider tokens, meaning that they are interest bearing. What it means that as soon as you provide, you send or supply the protocol, define a protocol with certain assets, like DAI, for example, the protocol prints you back LP DAI. And what is the idea behind? The idea behind that in time, the price of this LP DAI increases with the interest rate of the protocol provides you the yield. So taking it as an example, we have 100 DAI. We see that, for example, Definer provides us 12% APR. Let's imagine that it's a stable APR, and for the year it's 12%. It doesn't change. And then we Alice sends DAI, supplies DAI to Definer protocol, gets 100 LP DAI back, then holds this LP DAI, 100 LP DAI on her address for a year. And of course, why it's interest bearing? Because the quantity of this the LP DAI during the year will not change. So it was 100 LP DAI at the beginning. That will be 100 LP DAI at the end. But if we had the ratio of LP DAI to DAI at the beginning of the year, which is equal to 1, in a year, it will be not 1-to-1, it will be 1.12. So it will be 12% plus. And when Alice will try to withdraw liquidity after the year, she will get not 100 DAI, but she will get 112 DAI. So that's the idea of so-called interest-bearing tokens, very important one. And all lending protocols like Aave, if actually Definer very close to what Aave second version is doing, and Compound second version is also quite the same. They all work with this notion of interest-bearing tokens. Of course, you can send these tokens to other address. As soon as you will do it, you will actually lose your deposit. And this is like very close to the deposit certificate in banking. Maybe sometimes you use this but it's quite rare. When you bring deposit to the bank, gives you a paper which called the deposit certificate, and then you can also use this deposit certificate as a means of payment. So that's also may happen. So it's very close. They're very close idea, but on blockchain. The second actually principle is we have to understand how interest rates are calculated. Because if we provide, we've been talking on the previous lecture about how interest rate determined on AMMs. Here, we cannot also allow actually not the interest rate, but the ratio of in AMM. Here we work with the interest rates. And we also have to understand that if we will use the fixed rates, it will not work, because for someone it will be expensive, for someone it will be low. If we set a very low interest rate, let's say 1% interest rate for stable coins, then we will run out of liquidity. No one will want to bring more liquidity for 1%. And we will end up with the situation when zero liquidity in our liquidity pool. You cannot get back your deposit. You are not happy with it, so the protocol will not work. So we need somehow to have a dependency of so-called utilization ratio of the pool with the interest rate. So what is utilization ratio? It's U on this formula. We simply divide how much assets we borrowed to how much assets we have total in the pool. So for example, if we provided 100 DAI to the pool and we take 10 DAI as a loan, 10 divided by 100, we have 10%. So our utilization ratio is 10%. Why? Because as soon as you taken 10 DAI from the pool, you have 10 DAI as a borrow and you have 90 DAI as a cash. What might also happen is that as soon as let's imagine the situation when you took 100 DAI as a loan, then we have 100% utilization ratio, meaning that we do not have anything left in our liquidity pool. And it also means that if Alice comes to our lending protocol and tries to withdraw her deposit from the pool, she will not be able to do it because nothing left in the pool. So, and the first formula we use is the borrowing interest rate is equal to some fixed minimum amount, let's say 5%, plus some additional interest rate depending on utilization ratio. And you see here, if utilization ratio is low, it's 0, for example, then we have just 5% interest rate for the borrowings. If we have utilization ratio 100%, so it's equal to 1, 5 plus 1 multiplied by 30, we have 35%. So it's different. With 35%, it's more interesting to bring something to the pool, and this is how it works. So actually, that's the principle by which the interest rate is determined on almost any lending protocol today. For some exceptions, which we will talk later, that's the Frax protocol. They provided quite novel ideas of this interest rates curves. But here we use actually two curves. One is quite soft one, that's the red one. It's growing not so fast. But as soon as we cross some utilization ratio, in this case it's 70%, then we use another one, the blue one. So why is that? Because we do not want to have a zero liquidity in the pool, and that is why we need this steep blue interest rate curve to have a much faster growth of the interest rate. And when we have with the utilization ratio of 75%, the interest rate close to 25%, then we expect that someone else will come, bring more deposits. As soon as they supply more deposits into our liquidity pools, the utilization ratio will fall and the interest rate will decrease. So this is how it works. So it's two equations. We have some optimal utilization ratio, and we define it ourselves, setting up the parameters of the smart contracts, and we can change it. It can be 75%, 70%, 40%, whatever. So, and supply interest rate actually is calculated from the borrow interest rate. How we take the borrow interest rate, then we actually take away our reserve factor, multiply by utilization ratio. That's what our depositors or suppliers or lenders get as an interest rate. Another quite complicated concept, which is connected to actually the ability of smart contracts to work with a large number of deposits, and how to avoid this extreme number of calculations and save on the gas fees is actually this per second rate accumulation mechanism. I will not deep dive into details how it works, but the idea behind is that we will calculate 1 second interval, and we understand by which interest rate each second we have to increase our initial interest rate. Then what we do actually, we have so-called normalized amount. So as soon as you supply anything to the pool, the smart contracts keep record of the amount you provided, not the amount you provided, but normalized amount. Normalized meaning that it is divided by some factor which is calculated like this. That's the error rate, and this error rate is changed every time you interact with the smart contracts. You may change interest rate, you may add something, you may withdraw some liquidity, but every time we understand that we have one error for all deposits, and all deposits are kept in smart contract normalized, meaning that that's the amount which would have been at the beginning of the time the smart contract started to work with accepting the deposit. So it's T0, it's T0 time in the past. So now that's actually calculation of per second rate for if we want to achieve half of the % annual interest rate. So it's 1.0000. You see. So this is how this interest rates worked and calculated on smart contracts. Now liquidations. Of course, we need liquidations. Why? Very simple idea. Again, let's remember CDP, collateral debt positions. Here is the same principle. If you, for example, provided Ethereum as a collateral, take DAI as a loan on our lending platform, then price of the Ethereum drops suddenly. Of course, we see that your loan is under collateralized, meaning that it's not enough collateral to cover the loan in stable coins and DAI that you've withdrawn from the pool. You do not want to repay your loan. You do not want to add collateral for some reason. Maybe you don't have this collateral additional. Maybe you don't have these stable coins anymore. And then someone else, the third party, the keeper or the liquidator will come, and what they do, they repay your loan and get complete or part of your collateral with a certain discount. Here, this is exactly what happens. And why we can provide our liquidator with the discount on your collateral. That's because we do not have 100% collateralization ratio. It's always higher. So it's 120, 150, meaning that we have this 20 or 50%, the gap. And this gap allows us to cover the loan, to pay the bonus for the liquidator, and to even have some liquidation fee for the protocol. So this is how it works. And if we look at the DAI example, The DAI actually, the MakerDAO protocol have this Dutch auction. Here it's much more simple. There's no more, there's no any auctions. There's just, you come to the protocol, and if you are the first, you repay the loan and get the collateral with the discount. That's it. What we also have in our define a protocol, that's the so-called adaptive asset pool rewards. What I'm talking about. Actually, what in what way this lending protocol different from the classical banks? And one of the things is that in a simple bank, you cannot get additional token reward to your deposit. But in the crypto industry, in the crypto world, you can have it. Meaning that if you provided Ethereum as a collateral, as a deposit, you supplied it as a lender, of course, you will have some interest rate on this Ethereum if someone taken a loan. If no one takes a loan, then there's no interest rate. But what we can do additionally, we can pay additional interest rate to this in different token, not in Ethereum, but maybe in a governance token of our lending protocol. That's we're referring to this liquidity mining, staking, rewards, this type of stuff. So in here it works the same, but actually on Compound it works, and if you provide some collateral in some token, you definitely get part of the reward in the comp token. That's the comp token. That's the token of the Compound protocol itself. But usually that's the fixed reward per block, meaning that the supply reward is not connected to the borrowing reward. In our definer protocol, we actually connected it. And what we did, we stimulate the part of the equation which is not developed enough. We have a low utilization ratio. So U is the current utilization ratio. Low meaning, for example, it's 0. So we have only deposits, no one takes a loan. Then, according to this formula, the major part of all rewards goes to the borrowers, and we stimulate borrowing. It means that actually 90% or even 100% we can set up this formula as we want. That's the adaptive asset pool rewards. So all our pool tokens reward goes to the borrowers. As soon as borrowers will start borrowing something, and the utilization ratio is growing, then we get to the point when we have very high utilization ratio, we have lack of liquidity, and in this situation, on the contrary, we move the major part of our rewards to the lender side, to the suppliers. I will show you how it works on the example of the definer just in a few minutes, so for you to understand what I'm talking about, because from the formula it's difficult to understand. That's asset parameters in the smart contracts. Actually, if we have a certain asset, we want to introduce this asset for the lending protocol, for definer. In our example, we have to set this specific parameters. So that's the ERC20 token address, what address it is. Then we have to specify the main oracle, because you have to understand that this type of lending protocols rely on oracles, meaning that we have to take from some contract the price of our Ethereum in relation to the DAI, to the stable coin, or Bitcoin to the Ethereum, or something, or for example, BNB to USDT. And where we can take it from some Chainlink Oracle. So that's, of course, the weak point. If the Oracle is compromised, then we will have problems, definitely. And some hacks were connected exactly with this. I remember when Compound was relying on Oracle from Coinbase, as far as I remember, and some whale tried to manipulate the price of actually the stable coin, and that actually led to cascade of liquidations, and people lost lots of money. Then we have the backup Oracle, for example, taken from AMM. You know that the Chainlink is the one of type of oracles. The AMM can work as an oracles too. And if we have the pair with the high liquidity, the huge volume, millions of liquidity in it, so it's hard to manipulate, and then we can take it as an oracle also. Then is collateral, which means that do we want this specific asset to be used as a collateral? If it's stable coins, if it's assets like Ethereum or Bitcoin, then it's okay. If it's low liquidity tokens, which is not popular, or let's say have a high volatility, then we will not want to use it as a collateral. The four following parameters is actually, that's how we define our two interest rates in interest rate lines, the red one and the blue one. That's the base percentage, utilization breaking point, the first slope and the second slope. And additional parameters, max utilization ratio, that's the maximum possible asset utilization ratio, meaning that we define, for example, that we will allow only 80% of value of our collateral to be taken as a loan for Ethereum, maybe 60% for Bitcoin, maybe vice versa, maybe something else. Liquidation discount, that's the discount which received by liquidator, that might be up to 10%. And we have to understand that if we set up collateralization ratio 120, we cannot set up higher than 20 liquidation discount because it won't work. Reserve factor, that's the protocol income, collateralization ratio, rewards per block, protocol governance token paid on top of the base interest rate. That's what I was talking about. Additional liquidity mining token, minimum supply part and minimum borrow part. That's to define our adaptive asset rewards. So what extensions are possible for our definer protocol? And part of them we already have. That's the stablecoin module, how we can work with a stablecoin. And actually, Aave is trying to launch their own stablecoin called Go. How it works? You have billions of assets on Aave, for example, or millions of assets on any other protocol as a collateral, and you can print your own stablecoin using some oracle. And because you print it, you can provide whatever loan, the interest rate for the loan you want. So it could be stable. It will not depend on any factor because that's not external to you asset. That's asset that you may print, and you may print it, issue it, mint it as much as you want, depending only on the number, on the volume of collateral you have in your smart contracts. So that's the stablecoin module. Also, we have NFT platform reputation tokens, meaning that if you behave well, do not allow liquidations deposited a long time ago, maybe 6 months ago, then you might have better conditions, better, let's say, utilization ratio, not better collateralization factor, lower rates, maybe higher rewards in the governance token and something else. Then risk management administration module, that's for those who administrates the platform, because you need to set up, maybe change in time the parameters, and of course you need to make it more user-friendly, not making direct transactions with smart contracts. Connection to digital identity, that's also possible if you have zero knowledge proof identity issued to you by some other party. Then you might use it, and you can launch some KYC past actually pools where you can only supply if you pass through the KYC. Then decentralized fixed term deposits. Here we were talking about only about on-demand deposits, meaning that you can supply, you can withdraw at any time. But if we would have ability to set up the fixed term, maybe months, maybe 3 months, during which you cannot withdraw your liquidity, then we might think about paying you higher interest rate. The credit delegation, accepting NFT as a collateral, and we will talk about it on the example of the blend protocol. Then, of course, EVM compatible multi-chain interoperability, which is quite difficult today, but it's also great stuff. And lending protocol uniswapization, meaning that on Uniswap you can create any pair of tokens. Here it's not possible because only the administrator of the protocol determines which tokens allowed and which are not to be used as an asset on a protocol. Here, actually, we might think about letting any token to be used as actually token which can be lent on the platform. NFT platform reputation token, we were already discussed it. So it's higher collateralization ratio. So it's like a credit history. If you have that positive credit history with the protocol, then that's fine. Let's have some additional perks and bonuses. If not, then you can earn it by having good behavior for, let's say, half of the year, maybe 3 months. And then you can claim this soul-bound token, which you cannot send to anyone. It's stick to your address. You can only claim it, use it on the platform, and if you wish, burn it. And that's it. Okay, now let's go to our test case. That's our define a protocol. This is exactly what we have. That's the reward tokens, which are calculated according to this asset, adaptive asset rewards dynamic asset rewards formula. And how do we actually provide some supply deposit? You have this token with which you can, I send you one token. Here is, I have more, but you have this token. That's actually used as a gas fee. And you can also use it as a deposit. You can supply it. So when I supply one token, we see that the interest rate might change, and the distribution API also have to change. But let me provide more, maybe 10. Confirm everything happens with transactions. So you only change the state of a lending platform of this on-chain bank by sending the transaction. And why we need it? Because no one can come and actually take your deposits. So that's the idea. That's the whole idea of DeFi. It's all in smart contracts, and the smart contracts work according to the program, the code. Our definer protocol is audit. It's as a security audit. It's actually open source, so anyone can come and say that nothing is actually there's no functions which let the administrator of this protocol to take your deposit. So we did it. We had distribution APY 6,000. Now we have 2,000, meaning that that's of course the idea. So it means that this part is decreasing because we have more deposits. Now you see the utilization ratio is 5%. It's quite low. And that is why we have the high borrow distribution APY. But this APY is not in Ethereum. This APY is in our token, this RTK token, this one. So if we want to see how this part is changing, and of course, if we want to earn more because it's quite low interest rate, we have to borrow. Let's try to borrow 18 ethers. And then, of course, what happens? We have 88 utilization ratio, which was 5, now 88. And you see here that the interest rate is much higher. As a depositor, I also get higher interest rate. And if we look at this distribution APY, this adaptive APY, we have this 4,000 and here 16,000, meaning that now what our protocol is saying us that I, as a protocol, interested in deposits more than in loans. So that's the whole idea. So these interest rates are changing. We can also, you have also another token, which is BTC. I sent one BTC to everyone. So what you can do, you can actually supply. I have more. I have 1,000 BTC, which is of course the test one. Let's see what happens. Utilization ratio is 0, which means that all interest rate is here now. We interested in providing the loans. We want someone to borrow. Of course, after I provided even more Bitcoin, it's almost the same, but as soon as I want to have a loan, let's say this amount, what we will have in the end, we have different utilization ratio and different interest rates in Bitcoin, and different additional this liquidity farming APY. So this is it. I have 64 utilization ratio. I have high interest rate, and I have different relationship of the interest rate. It's almost the same. But now you see that we're more interested in deposits now because we have higher utilization ratio. So collateralization ratio is here. Liquidation discount, max utilization ratio. That's I cannot actually borrow for more than 96% from the pool. So you cannot. I will not be able to take loans for more than 96%. So that's just for liquidations. You see here that even maybe there's some liquidations already possible, so we can liquidate someone, but I will not do it now. And I can, of course, claim my rewards. Oh, it's not working. It's different. It's funny. I don't have these rewards, so that's the point. Someone has to send these rewards to the pool. So that's why I cannot claim it. We did not provide so much rewards here. That's now I understand why it doesn't work. So I can see my supplies here, what I've supplied as a collateral. I can see what I've borrowed. And this is what you can do yourself with this. If you need more, just write it. I will provide you maybe other assets. I also have USDC, DAI, and I think USDT. How to understand what you have on your address? These links are also under your task. You can actually go to the to the blockchain explorer, enter your address. That's what I did. It's my address, and see what tokens you have. And then, if you want to see these tokens in I have 1 million USDT, 1 million USDC. If you want to see these tokens in your MetaMask account, you have simply to copy this address. That was I was showing you, I think, last time, but I will do it once more time. Go here, go to assets, import token, enter this address, add customer token. You see, I have my 1 million. Now I can send it to anyone. And of course, I see this 1 million also here. If I go here, wallet balance, almost 1 million. But actually, why it's not 1 million? Because it's using Oracle to calculate the value in US dollars. So today, USDC ratio is a little bit lower than $1. It's 0.999995, and that is why here it's not million, but it's only almost 1 million in US dollars, but it's 1 million in tokens. So that's how oracles are affecting the amount of the number of tokens I see. That's 1 million. So the reserve size, that's what our protocol earned for today. And all parameters we see here. And what we also see here is that we can use all assets as a collateral except for USDT. It means that if I provide USDT supply for the deposit to the protocol, I will not be able to works. So that's it for the practical part. Do it yourself, play with it. Need more tokens, I will send it to you. And now the third one, the last point for the lecture today is the question about USDJ. USDJ is actually stable coin. And what happened with USDJ? Usually in 99% of the cases, we see that the peg of our stable coins, which leads to the lower rate in relation to the US dollar. So it means that the peg leads to our stable coin costs 99 cents, 90 cents, 1 cent if we take the Terra dollar. But here it's quite the opposite. So it's strange. Why our USDJ stablecoin was growing to almost $2.50 for 1 USDJ? Why it happened? So I almost set the mark 4 and higher to everyone who said manipulation, who used the word manipulation. Definitely it was manipulation by one of the whales. And why they did it? Because they wanted to earn money. And how they did it? They did it using the lending platform. This was just what we was talking about. You see that Just lending platform. What we have here assets. We have USDD stablecoin, supply APY 5%, borrow APY 2%. And we have our USDJ stablecoin, supply 0.76, borrow 1.07. And what a lot of people do, they were thinking that USDJ is stable coin it will never be higher than, I don't know, 1.10 US dollar, maybe. But it was, at some point, it was $2.5 US dollar. And what they did, they actually, for example, supplied the deposit in USDD and then taken a loan in USDG. You have here a deposit under 5%, loan with 1%. Then what they did, they exchanged USDG to USDD again, supplied USDD here, and then taken again a loan. And did it a few times. And they pushed their collateralization ratio in the liquidation to the limit. And they were thinking that USDJ is really stable coin. But that whale manipulated the price, increased it to the 2.5 US dollar, and it led to the liquidation situation when they had a huge debt. Debt increased 2.5 times, and they had not enough collateral. And this whale actually liquidated all of them, liquidated millions of stable coins, earned, I think, a few hundred, if not million US dollars on this manipulation. That's what happened. And then, of course, the price decreased, but now it's 1.12. What this whale did, actually, specifically, he or she, I don't know, who is it, withdrew money from the liquidity pool. That's this liquidity sun swap works exactly as the curve. It has 3 stable coins, and when you withdraw liquidity from USDJ part, it's only 6% even now. What you see here, if you try to change USDT to, let's say, 1 USDT to USDJ to USDT, you have 11 for 10. 10 USDJ, now it's 11 USDT. It's still not actually unpacked. But that's a different story. Why it's unpacked? Because from my point of view, the problem with USDG, that USDG does not have so-called PSM module, which the DAI have. We were talking about PSM, price security model. What this model allows to do, it's actually simple smart contract. When you provide to the smart contract, for example, USDT, and this smart contract prints you 1 USDJ. So it's a relation 1-to-1. This USDJ does not have this functionality. It has only, you can only print USDJ when you provide the TRX token with the ratio 150 collateralization ratio, but taking into account that you might find more interesting use cases for your TRX, earning more money on your TRX, the real cost of printing USDJ is about 1.1 US dollar. So this is like market estimate for the real price and how it costs. So it's not the stable coin anymore. It's like some weird stable coin which is pegged 1.1, not 1-to-1, for the reasons I've just mentioned. As soon as USDJ ecosystem and the governance will introduce this PSM module, it will work quite well, and the peg will be restored to 1-to-1. By the way, they have PSM, but only for USDD. That's another token. USDD, you can always exchange 100 USDT to 100 USDT, but not vice versa, because it's empty for USDD. USDD is a different story. So that's it for today. I think the lecture was interesting for you. Thank you for your attention. Let's see the questions. Actually, my vault is still empty. Okay, maybe you connected to the different network, not the token E, because you need to connect to token E network. Send me the address and I will send it again and give you even the transaction. Does distribution borrow API allow borrowers to earn on borrowing? Yes, it does. And in my case, that was actually what was happening. As soon as you see that the additional borrow API in this governance token is higher than the API you pay in the native token, then you actually earn on borrowing. But it's also risky. Why it's risky? Because we pay the protocol pays you rewards in the volatile token. It means that today the price is X, yes, tomorrow the price is Y, so it might decrease. And if it decreases, all your, let's say, rewards in this token might be depreciated according to the price decrease. And that is why if you wanna, you can actually earn on borrowing, but you have to look after the price of the asset you're getting the rewards in. So that's it. Thank you.
Okay, thank you for a lot. And now I'll add this presentation and recording of this lecture, and see you soon.
See you.
Thank you very much. Bye-bye.